Hello guys, welcome back to my channel. Today I will be discussing problems of today's Codeforces round 884 Div1 plus Div2. So I was able to solve first three problems and I was not able to solve the fourth problem during contest. I think I was missing something. Anyways, so in this video I will discuss second problem, and in next video I will be discussing third problem, C problem, particles. So I will be not discussing the first problem because it was quite easy, so most of you have done that. So cool. So in this video I will be explaining problem B, permutation and primes. So let's understand the problem statement first. So we are given a positive integer n, and max is defined as the smallest positive integer x which does not occur in the collection C. Okay, and a word primality of an array is defined as the number of pairs this and such that mex is a prime number. Now we have to print a permutation of n numbers such that there will be maximum possible primality among all permutations, right? And in the note section we are given definition of prime number and permutation. That's unnecessary. Okay, and constants are as usual, so we can use one for loop. So let's understand its logic first, then I will explain you the code. So let's say we have n is equal to 5. Now first thing we should keep in mind that first let's just write 5 numbers. So now can you tell me if I want maximum sub-arrays in which mex is a prime number? So what we can do? So we have to maximize number of sub-arrays having max as prime number. That's what we have to do. Now if we want to maximize the number of sub-arrays having max as a prime number, so if we want a max as a prime number, so one thing is clear that we have to put 1 in maximum number of sub-arrays. Why so? Because if 1 will not be present in maximum number of sub-arrays, then obviously the max will be 1, and 1 is not a prime number. So if I ask you where I should put this 1, so just think, and you can think that we have to put 1 in the middle of the sequence. So let's put 1 in the middle. So we have 5 elements, so at the third position I have put 1. Why I have put 1 in the middle position? Because we want 1 to be present in maximum number of sub-arrays. Because if 1 is not present in maximum number of sub-arrays, then in most of the sub-arrays 1 will be the mex, and we don't want that because 1 is not a prime number, right? So we have put 1 in the middle. Now what are the two smallest prime number? So it is 2 and 3, right? So tell me where I should put 2 and 3. So with a simple observation you can say we have to put 2 here and we have to put 3 here, and we can put other elements randomly anywhere. So I have put 4 here and 5 here. Now let's see. So now see, if I take sub-arrays, so let's take this sub-arrays. So its mex is 1, so it is not prime number. We take this, so its mex is 3. Now why I have put 3 at the right side and 2 at the left side of 1? Because in all sub-arrays, this one, this one, dot dot dot, so on. 3 will be the MEX, right? And similarly in right part, in this subarray, this subarray, so on, 2 will be the MEX. So we are by doing this we are maximizing the number of subarrays having MEX as a prime number. So once again I will explain it. I think I have explained it quickly, so I will explain you again. So let's take a same example again so that it will clear. So we have n is equal to 5. So first thing what I have told is we have to put 1 in the middle because we want 1 to be present in maximum number of subarrays, because if 1 is not present in maximum number of subarrays, then no any prime number can be the MEX, because 1 is not present and it is the smallest element which is not present. So 1 will be the MEX and 1 is not a prime number, right? So that was the observation, and we have to think that. Now we put 2 smallest prime number 2 and 3 here, so it will be beneficial, because when we take, and why we have put 2 and 3 at the end only, because all the subarrays that I will take before the starting, I mean between 2 and 1, so this one, the MEX will be 2 only, so it is a prime number. And similarly in this side, if I'll took this one, then the MEX will be 2, and if I will take this one, so the MEX will be again 2, right? And if I'll take the whole this subarray, then the MEX will be 3. So in this way we can maximize the number of subarrays having prime number as a MEX. So primality of an array is maximized in this way. So the code is pretty much simple. So this is the code. So I have separately put for n is equal to 1, I will directly output 1. For n is equal to 2, we can output 2 and 1. Now for n is equal to 3 and onwards, I have made a vector v, and I have put all the elements up to n first. So let's suppose for n is equal to 5. Now what I have done is I have swapped this one and this one, and this one. So 3, I have placed 3 at the end of the vector, so it is 1 2 5 4 3. Now at this step I have swapped v0 and v1, so v0 and v1, so v is 2 1 5 4 3. So basically we are putting 1 to the middle. So in this step I am putting 1 to the middle, so v is equal to 2 5 1 4 3. So this is the answer. So it was a quite tricky problem, I would say. So if you understood, then give me a thumbs up. Thank you.